Hey guys, and welcome back to another video on the channel. In today's video I'm going to be showing you how to solve a trigonometric equation. Now, typical trig equations has popped up all the time when you first learn trigonometry. So for example, when you have sine theta equals a half and you're trying to find that angle, what you would do pretty much is you would sine inverse both sides. So you get theta equals sine inverse of a half. Then you'd plug that into your calculator and it would spit out a corresponding angle. You can actually work out what this is straight away without using a calculator if you know two types of triangles. So if you know your 60 degree, 30 degree triangle, so where the ratios of each side are the square root of 3, 1 and 2, you can work this out straight away. Because sine is the same as opposite on hypotenuse, so if you label this triangle, you can label that as opposite and then hypotenuse, and then you can work straight away it's 30 degrees. So sine inverse of a half, without even using a calculator, is 30 degrees. Okay. Now, in year 11 and year 12 math methods and specialists, you're asked to solve similar things like this, except you're given kind of a restriction. Okay. So if you got given something like this, so this is still the exact same equation. All I have is just change it to x pretty much, but I've given you a domain now. So x belongs between, let's go, 0 and 360 degrees. Okay. So this is saying I want every single value of x which makes this true. Because theta, when theta equals 30 degrees, isn't the only solution where this is true. So there are a couple other angles where you sine them, you'll also get a half. Okay. So to find these, we need to graph the sine curve. Okay. So the sine curve looks something like this. So you have your x and your y. The sine curve looks something like this, okay? Now, this amplitude is 1, so this is just your casual y equals sine x, okay? So when solving a trig equation, for a sine or a cos equation, just graph the normal trig equation, and then you can apply any changes you have in your equation here to the domain and anything else. But for now, you don't need to change anything, so this amplitude is still 1, and this amplitude here is still negative 1, okay? These corresponding solutions, now, these distances, they're meant to look the same. The reason why they don't look the same is because I'm just really bad at drawing. But imagine they are the same. This drawing is just going to illustrate pretty much the idea. So this would be 0 degrees, so 0, 0. This would be 180 degrees, 0. This would be 90 degrees, and this would be 1. So that would be that coordinate up there. This would be 270 degrees. And this would be 360 degrees, okay? Now, they're not always going to have in degrees. They're most likely going to have the equation in radians. So the exact same question can be given like this. So I'm just going to change how it looks very quickly. So you get sine x equals a half, except they give it like this. So x belongs between 0 and 2 pi, okay? So for context, 360 degrees is 2 pi in radians, okay? Now, a radian is another unit for an angle, except it is the distance around the circumference. So 360 degrees represents a full revolution around a circle, okay? If you have a radius of 1, so the radius is 1, the circumference is 2 pi times r. But if your radius is 1, that means your circumference is 2 pi, okay? So 360 degrees represents this angle in here. But it can also represent the distance around the circumference. So a 360 degrees would be this entire green distance here. So that would be 2 pi radians. So that green is that physical distance there. What else? If you were to go to 90 degrees, so this angle here, this pink distance here would be pi on 2. So that means 90 degrees equals pi on 2 radians, okay? So your radian represents the distance traveled around that circle. So it's another unit for pretty much an angle, okay? But the reason why we do it like that is because you can use actual numbers with it. So when you graph this thing, it's the exact same thing here. So a sine curve just between, that is a terrible drawing, let me try that again, between 0 and 2 pi looks something like this, okay? So this is 2 pi, 360 degrees. This would be pi, 180 degrees, and this would still be 0, okay? This point here would be pi on 2, 1, that corresponding x value, okay? Now, let's just get into solving this trig equation. So we want to know when the sine curve, so this thing, is equal to the line y equals a half. Now, a half would be here. So we want to know when it equals a half, so you can just draw that line straight away. This would be the line y equals a half. Now you can see, in this domain, you have two solutions, okay? So what that means is we can find that first solution. If we find that first solution, because a sine curve and a cos curve are symmetrical forever, this distance will be the same as this distance. So if you find this first solution there, and you work out that distance there, you can work out every other trigonometric solution to this equation. So your first solution would just be, alright, solving this equation, so sine x equals a half. So x is sine inverse of a half. So you should get 30 degrees. So 30 degrees in radians is pi on 6. So if your calculator is in radians, you'll get pi on 6, okay? So that distance there is pi on 6 because you're going from 0 to pi on 6. So that means your first solution, so x equals pi on 6. Your second solution will be pi, subtract pi on 6. So pi minus pi on 6, okay? Let me just grab my calculator for a second because I might do it in a second. Sorry about that. If there's any extra noise, there we go. All good. Right, so pi minus pi on 6 is 5 pi on 6. And this one is still pi on 6, okay? So these two solutions, if you plug into your trig equation, should give you a half. So if you plug in sine of pi on 6 into your calculator, and now make sure you're in radians as well, it should give you a half. And if you plug in sine of 5 pi on 6, it should give you a half, okay? Let me just check that as well. I'll just put my calculator in radians, because if I get this wrong, that'll be very embarrassing. Oh, it's a half. Perfect. Thought so. Just still want to double check. Alright, I'm doing this video from pure scratch anyway. So yeah, those would be your first two solutions in this restriction. So this restriction is basically saying you want it between 0 and 2 pi. So imagine there's like a box there. You only want those two solutions, okay? Because your sine curve goes on forever, and so does it this way as well. So it goes on to positive infinity, and it also goes down to negative infinity. So with the trig equation, they will always give you a domain which you want your solutions, okay? Now it doesn't have to be this green box. It could be I want the solutions between this orange box. And if you extend that, you can see you're going to have 1, 2 more solutions, okay? So let's take a look at it with a cos equation now. So let's say we had cos of x equals root 3 on 2, okay? And you want the solutions, so x belongs between, let's go minus pi and 2 pi, just to be a little bit different, okay? So straight off the back, we've got to graph our cos equation, but we need to graph it in this region, okay? So between negative pi and 2 pi. So straight off the back, we know cos looks something like this, where this is 2 pi, okay? So all we have to do is pretty much work out where, if pi is here, we know cos is symmetrical, so it will finish about here at negative pi, but this would be that turning point. So this is pretty much cos graphed in its domain, okay? Now we need to work out where root 3 on 2 is. Now, we know for a fact the square root of 4 is 2, okay? And we know the square root of 1 is 1, okay? So that means the square root of 2 must be bigger than 1, okay? So that means definitely the square root of 3 must be bigger than 1. So if the square root of 3 is larger than 1, then that means the square root of 3 divided by 2 must be larger than a half. So you get the square root of 3 divided by 2 must also be larger than a half. So you know a half is about halfway. So that means your root 3 on 2 must be just a slightly bit above it. So you can draw the line like that both ways, okay? So this would be the line root 3 on 2, okay? Now from your drawing, you can see there's going to be 3 solutions, okay? You've got 1 in the negative region and 2 in the positive. So we've got 1 here and 1 here, okay? Now the cool thing about this cos curve is this solution is just going to be the positive version of this one here, because that distance there will be the same. And since it's going from 0, it'll be like going one distance this way and one distance that way. So if you work out this one, just times it by -1, and you've already got that second solution over there, okay? Straight off the back, that distance there, and then that distance here would also be the same. Okay, so we know what our distances are going to be, so now we got to work out that first initial distance. So I'm just going to move this down here. So solving this first equation, so x equals cos inverse of root 3 on 2. You can use your triangle, so you can go 60, root 3, 30, and 1 and 2. So cos is adjacent on hypotenuse, so root 3 is your adjacent and 2 is your hypotenuse, so it must be talking about 30 degrees because that angle is adjacent to this side of this triangle, okay? And we also know 30 degrees is pi on 6 in radians, okay? So that means this first solution is pi on 6, and the second solution here, or technically the first one, is negative pi on 6, okay? Then you can finally work out your last solution by going 2 pi subtract pi on 6. So your solutions to this equation, so cos x equals root 3 on 2 between negative pi and 2 pi are the following. X equals negative pi on 6, pi on 6, and 2 pi subtract pi on 6, okay? Which we can work out in a second. If you want to work that out very quickly, just ignore the pi's, just go 2, subtract the 6, and you'll find it's 11 on 6. So it'll be 11 pi on 6 are your 3 solutions here, okay? So what that means is, if you go cos, and make sure you calculate in radian, if you go cos of negative pi on 6, it should give you root 3 on 2. And you can double check that as well. So cos, I know the cos inverse, negative pi on 6. Yep, root 3 on 2. And then it should be the same for this angle as well. So cos of pi on 6 should give you root 3 on 2. And then finally cos of 11 pi on 6 gives you root 3 on 2 as well. Okay. If you have any questions about any of these examples we've covered at the moment, leave something in the comments, but I'll probably be making a follow-up video to this because these are your basic trig equations. But I think that's enough for this first video. Give it a thumbs up and I'll see you in the next one.